Hi to everyone. I'm Jaime from the UPV. I'm here with my colleague Josep and David from the UPV. We are going to present the implementation. This is a minimum implementation of the features of MBS. This implements a minimum set of features focused only on MBS broadcast, just to start implementing these capabilities and to test it and showcase how it performs and how it works. I'm going to explain the architecture very briefly, the features that our implementation has, the current development status, and later I'm going to explain the deployment in the sense of how we deploy the implementation here in our lab. And then my colleague Josep is going to present you a demo uh, establishing a MBS broadcast session and transmitting the multimedia content to the UEs that are receiving the transmission from the GNOB. So we have here the block diagram of the different network functions at the core and the elements of the RAN, so-called the GNOB and the UEs. Here are the network functions that are used in our implementation in the Open5GS based implementation, because we use Open5GS as a base from our work. The two main things that we did was the MBSMF and the MBUPF. This is the multicast broadcast versions of the regular SMF and UPF. And also we have a very simple AF just to send the content to the network and to be transmitted through MBS. Here I have a diagram that is showing the elements that are used in the transmission of an MBS session. So we have the AF, it's a content provider in our implementation that sends the establishment request to the core to establish the MBS broadcast sessions, and also sends the information that it's going to be transmitted in the cell. That is performed through the MBSMF, MBUPF, one for the control plane and the other one for the user plane, and that session is forwarded to the GNOB in order to establish all of the context of the MBS session, and the user plane information is sent to the GNOB in order to be encoded in the signal and transmitted to the UEs. Okay, here we have the different protocols that take some functions in the establishment of the session and transmission of the information. Pretty much MBS broadcast, it's a transmission mode of MBS that it's more simple than multicast, in the meaning that it has less functionality to be implemented in order to work, because you don't have the HRQ and so on. So it's more easy to implement, or less work to do the implementation than multicast. Okay, here I have a diagram of the actual implementation in the code. As I mentioned, the development started using existing implementation of the core and the RAN. For the core, we used Open5GS. In Open5GS, we used the SMF and the UPF in order to implement the MB version, so the multicast broadcast version of that network functions. For the GNOB, we used the implementation of SRS RAN, that is called SRS RAN project. And for the UE, we used also the SRS RAN implementation that it can be found in the SRS RAN 4G platform or suite. Here in this diagram is a diagram that shows how the GNOB is splitted. We have the CU and the U, and basically we transform or replicate the unicast implementation of the GNOB. We replicated and adapted to the MBS broadcast use case. Okay. What we did is just to implement the establishment of an MBS broadcast session that requires procedures and functionalities in different protocols and in different interfaces. Basically, what we did was just to implement the messaging between the 5G core and the GNOB in each different element. So the CU and the U, and the CU is split in control plane and user plane. So here are the messages that exchange different entity within the network just to establish the broadcast session. So these messages and this exchanging is what we implemented in the 5G core and the GNOP. For the RAN, that is the communication between the UE and the GNOP that affects only until the MAC layer, because the physical layer is the same as the unicast. It uses the PDSCH. And basically what the GNOP does is just to transmit the control information, that is the SIPs, and the actual logic channel, that is the MCCH and MTCH. Okay. For the moment, everything is static. So our implementation is only MBS broadcast, and it's only capable of established MBS broadcast sessions. That means that we need to add functionalities to NGAP, GTP, SDAP, RLC, and PDCP, and also to the interfaces F1 and E1. Some of that protocol interfaces are between the core and the CU, that is the central union of the GNOP, and the other part of the implementation is between the GNOP and the UE, and that affects to the distributed unit. For the moment, the configuration of the transmission, the implementation, you can establish a session, but the RAN configuration is static. So the UE knows that it's going to receive an MBS broadcast session, and there is not coexistent between unicast and broadcast. So that means that with our implementation, with our current one, you can't receive unicast and go to broadcast or the otherwise, or the other way around. So this is only an implementation that works transmitting MBS broadcast sessions. Okay, so there is no switch preselection between different cells and nothing regarding multicast. This implementation will be publicly available at the 5G MAR repositories once we finished implementing all of the 3GPP functionality. Because right now we have, as I mentioned, the RAN configuration is static, but it shouldn't. It should be dynamic. So you should change the session and change what is being transmitted at GNOP, and the UE should discover the new sessions and so on and so on. And once we did that, that means the implementation will be compliant with the 3GPP specification and will be completely functional in this, speaking about the MBS broadcast set of functionalities. Then that the implementation will be publicly available at the 5G MAR repositories. But if anyone wants to test it at the current status, it's possible. So anybody that is interested in test it and use it are welcome to request it and ask it, and we will give you access to the repositories. Okay, so right now, since the service doesn't require any functionality, we are not using the MBSF and MBSTF. These network functions are related to service layer functions. Right now we are transmitting video, so we don't need this. But in the future, we will implement and integrate the BBC's media streaming implementation with our 5G MBS broadcast implementation, and we will be able to use the MBSTS functions to transmit different multimedia content using different formats and so on. And now my colleague Josep is going to explain you how we have deployed the implementation and show you a demo.
Okay. Hi. Okay, so I'm going to explain the actual the deployment of the demo that we are going to perform now. So everything is running in a single virtual machine, and we use Docker containers to deploy each of the components of the system, and all of the components of the GNOS-B, the UEs, the core are connected over a Linux bridge. Okay. And here is a diagram of the demo. So we have an application function that first is going to create a broadcast session. So it will request the creation of a broadcast session to the core network, in particular to the SMF, and the SMF will configure the UPF and the GNOSBIS for them to be able to forward the traffic to the UIs. The implementation right now supports using one GNOSB and two UIs. So you can see that two UIs at the same time are receiving the same traffic, but we're only sending the traffic once from the IMF. And we use CMQ instead of a physical radio channel in order to have the full demo running in a single virtual machine. All the other, so the physical radio channel is not in use, it's simulated instead. But all the other radio protocols are implemented in the GNOSBIS and the UIs. And you can see in the diagram that on the left side, the DAF sends the video traffic to the UPF, and the same traffic will be received in the UI side and reproduced in a media player. So I'm going to share my screen now. One moment. Do you see my screen?
Yeah.
Okay. So in this terminal right here, I have I show you all the containers that implement all the components. So first of all, I'm going to restart it. So we start.
Josep, we see the background. So I only see a background right now.
Okay, maybe I'm sharing the other screen. Okay. Do you see it now?
Yeah, now we see the console. Yeah.
Okay, I was sharing another screen, sorry. Okay, so in this terminal right here, well, I'm showing you like this. Here are all the containers that implement the different components of the system. So the UIs, there are two UIs, the GNOSB, and all the core network functions. So I'm going to restart it. So we start with a fresh system. Okay. And now I am going to, in the terminals in the upper side, I have one UI in the left side and one UI on the right side. So there's two different UIs. And I'm going to start a media player that will receive the traffic. Okay. So now, in order to send the video, we need to perform a request to send to create a broadcast session. So we execute the request, and we in the request body we are asking. I'm going to make it bigger. Okay, so we are asking for a session of type broadcast, and we are saying here that this multicast group will be used in the session. Okay, and now I will send a demo video, and it will be received in the two different UIs. Okay, so now we see that it works, and we can also see the real video being like this is a player that reproduces the video with a speed cartridge for the demo. But now I'm going to use I'm going to save the video and play it in a real player. Okay, save video. And I'm going to send the the trailer of the big Bugs Bunny movie, and we wait a little bit so we receive more seconds of the video. Okay. Now I'm going to copy the video to my computer and play it. Okay. So this is the video received by the two user equipments. As we saw, there seems to be a different a delay between the videos, but it's only because of internal buffers of the video player. And okay, so this is the demo.